In lesson 4, you're asked to find the sum of a sequence, which is really called a series. The sum of a sequence is called a series. So, we were working with sequences for a while, and this one deals with arithmetic. Geometric is in the next lesson. We were dealing with sequences for the first few lessons, and it was a list of numbers. What you're doing here is you're adding all of those numbers. But instead of having to add, let's say the list was all the odd numbers. Imagine you there, 1 plus 3 plus 5 plus 7 plus 9 plus keep going forever. They actually came up with this formula. This is the most important thing you need to take from this lesson. S sub n equals n over 2 times a sub 1 plus a sub n. So what you need to know from this formula, n is going to be the number of terms. And sometimes they'll tell you, sometimes they won't. So anywhere you see an n, you put the number of terms. A sub 1 is going to be the first term. And a sub n is usually going to be the last term, but it really depends on n. We'll look at some examples later where a sub n wasn't necessarily the last term. But when you're dealing with this formula, it will be. So let's get right into an example. The first example is also from the lesson. They wanted the sum of the first 100 natural numbers. So first, natural numbers are just all positive integers. So 1, 2, 3, 4. So we would be here adding 1 plus 2 plus 3 plus 4 plus all the way to 100. And we would be here forever. However, if we use this formula, we can find the sum easily. So first, n, how many terms? Well, we're going to have 100 terms, the first 100 numbers. So n is 100. Our first term is 1. And our last term, our 100th term, is actually also 100. So we just take all of these and plug them into this. When we do that, we get S sub 100 equals 100 divided by 2 times the first term plus the last term. And we got S of 100 equals 50 times 101, which we end up seeing is 5,050. So the sum of the first 100 natural numbers is 5,050. In the rest of the lesson, you're giving opportunities to use this formula to find the sum of terms, but you're not always given all the pieces of information you need. This one is the easier one. They tell you right in the beginning that there are 16 terms. So I would suggest writing out the information you know. We know the first term here is -10. And we know the last term is 50. So we're good. We just plug into this formula. The sum of those 16 terms is 16 terms divided by 2 times the first term, -10, plus the last term, 50. So the sum of the 16 terms is 8 times 40, which gives 320. So part B is slightly more complicated than part A. Part A, you're giving every piece of information, but in part B, you're not. You are given the first term, which is -8, and you're given the number of terms. So you're given, let me use the same color as before. We're given the number of terms is 20, and we're given that the first term is -8. What we don't know is what the last term is. We don't know that. So we can't plug it in. However, we are given something very important, which is the common difference. So I want to take you guys back to lesson number 2, where we're given the explicit formula, a sub n equals a sub 1 plus d times n minus 1. This formula would allow us to find any term that we want as long as we had the first term and the common difference. So right now we want to find the 20th term because if there's 20 terms, we know that the 20th is the last one. So since we want to find the 20th term, we take the first term, which is -8, plus the common difference, which is 6, And for n, we're plugging in 20. This formula right here will give us the 20th term. So it's negative 8 plus 6 times 19, which gives us 106. That means that the 20th term is 106. So now we have all the pieces that we need to find the sum. And again, we're using this formula right up here in pink. We're going to plug in all of these numbers to that formula. So to find the sum of the 20 terms, we take the 20 terms divided by 2 and multiply it by the first term plus the last term. So to find the 20th term, we're doing 10 by 98. So that means that the sum of the 20 terms is 980. So that one was slightly more complex than the first one because we were only given the number of terms and the first term and the common difference, which we use our explicit formula for an arithmetic series sequence to find the 20th term. Once we had the 20th term, we plugged into the sum formula and got our answer. Example C is similar to example B in that we're not given one of the terms we need. We are told that the last term is negative 29. So the last term will be negative 29. And this is the common difference is negative 3. Well, we are actually given the number of terms too. If a sub 12 is the last term, that means there are 12 terms. So n is 12. What we're not given is the first term. We don't know what that is. But again, just like in the previous question, they gave us the common difference. So we are going back to our same explicit formula that was to find any term. You take the first term and you add it to the difference times n minus 1. So we're going to use this formula to help us find what the first term is by using what we know. We know the 12th term. The 12th term equals the first term plus the common difference, which is negative 3, times the 12 minus 1, because this is all the information for the 12th term, and we're using it to find a sub 1. Well, we know the 12th term is negative 29. We don't know what the first term is. And negative 3 times 11. We just keep on simplifying this until it gives us what the first term is. We'll add 33 on both sides. And we end up getting that the first term is 4. So that one was a little bit more complicated because we needed to know exactly what to plug in to find the first term. So this is actually 4. And we have everything we need now to plug in this formula. So the sum of the 12 terms is equal to 12 divided by 2 times the first term plus the last term. So S of 12 is equal to 6 plus negative 25, which is equal to negative 150. I feel like example D is the most complicated yet because they still want you to find the sum of this sequence and all they give you is the sequence. The first term is 5. We know what the last term is. It's 77. What we don't know here is how many terms there are in total. We don't know that. So we're going to go again back to our handy trusty formula. A sub n equals a sub 1 plus d times n minus 1. So we're still going to use our last term. We know that our last term is 77. We know that our first term is 5. And we actually know our common difference. If you look up here, these are increasing by 3. So we know our common difference is 3. What we don't know is our n, and that's what we're going to find. So let's simplify this. We get 77 equals 5 plus 3n minus 3, because we distribute. Combine like terms, we get 77 equals 5 minus 3 is 2 plus 3n. Subtract 2 on both sides. 75 equals 3n. And our last step would be to divide by 3. And that will tell us that we have 25 terms. So we just found everything we need to find the sum of this series right here. To find the sum of this sequence. So I don't have too much room here, so I'll do it here. The sum of the 25 terms, I just found out it's 25, is equal to 25 divided by 2 times the first term plus the last term. So the sum of the 25 terms equals 12.5, right? Because 25 divided by 2 is 12.5 times 5 plus 77, which is 82. And when you actually multiply, you get 1025. So the sum of the sequence is 1025 of the first 20. The last problem that I want to talk about is actually the last one in the lesson. And it talks about Kirk. He's depositing $100 per month in an account. So that means the first time he deposited 100. Then he decides to increase the amount he deposits by 10 per month. So however much, if he put in 100 the first month, he's going to put in 110 the next month. He's going to put in 120 the next month, and keep on increasing the amount he puts in by 10. So let's start this sequence, right? He starts by putting in 100. Then he puts in 110. Then he puts in 120. Then he puts in 130. All the way, right? To something else. They want to know how much money is he putting in after 10 years. So one thing we need to remember is that if it's 10 years and he's putting in money monthly, then that means since there's 12 months in a year, he's putting in 120 payments. That right there tells us our term number. Our term number is 120. What we know is that the first term is 100. We don't know what the last term is, but we know that it's the 120th term. So just like we did in previous problems, we use this formula, the explicit formula for a arithmetic sequence, to find out what's the last payment. What is it? We know it's the 120th payment, but what is it actually? 120 times, a sub 120 equals the first term of 100 plus the common difference of 10 times the 120th term minus 1. Well, we have 100 plus 10 times 119, which is equal to, if we just plug all of that right into our calculator, 100 plus 10 times 119, that gives us 1,290. That means that the last amount that he put in was 1,290. And now we have everything we need to find the sum. We know the last term was 1,290. So we have our first term, our last term, and our number of terms, which we're going to plug right back into this formula. The sum of all the terms is equal to the number of terms divided by 2 times the first term plus the last term. The sum of these 120 terms is equal to 120 terms divided by 2 times the first term, 100, plus the last term, 1,290. So I'm simplifying. 120 divided by 2 is 60 times 1,390. And then when we multiply, we get that at the end of those 120 months, at the end of those 10 years, this is how much money will be in the account.